Hello, Happy New Year and welcome to this recorded session. My name's Katherine Milner, and after teaching maths across the primary age range and then working as a local authority maths advisor, I'm now an independent primary maths consultant and have been working with schools across the country in this role for the last 9 years. So this session is going to focus on using research to make decisions about the use of mathematical representations. If I'm honest, when I was teaching, I don't think I made as much use of research as I could have done. It was only when I became involved in delivering training on the Maths Specialist Teacher Programme and also teaching maths education on undergraduate and postgraduate ITT programmes in a university setting that I became more exposed to research and started to consider the importance of firstly being aware of what the research is saying, and secondly considering the implications it has in terms of classroom use. I would now say that all sessions that I run, all training or work with schools is actually really grounded in research. You might find it useful before we go any further to pause the recording and gather together the resources that are on this slide. So today in this session we're going to be thinking about the different types of mathematical representation and clarifying what we mean by each. We'll then move on to think about the reasons we might have for using representations, before then devoting the majority of the time to the final bullet point here. How do we decide which representations to use, and how do we decide how to go about using them? So of course the whole session is going to be in relation to research, through exploring what the research says, looking at some specific examples, and then also providing some opportunities for you to pause the recording to reflect on your practice and have a discussion with your colleagues. To begin with, we'll consider the different types of representation. Depending on where we look, we might find slightly different definitions, but for the purposes of this session, we will be considering the following. So concrete resources to be the things that can be picked up and handled, sometimes referred to as manipulatives. So other examples of this might be Numicon, bead strings, base 10 equipment, for example. The concrete pictorial abstract, or CPA approach, is one that we have probably come across, and in fact is developed from the work of Jerome Bruner in the 1960s as a way of scaffolding learning. His terminology, however, was slightly different. One of the common myths of this approach is that we should expose children to the representations in the order they appear on the slide as a linear progression. So first children work with concrete representations, then once they've secured their understanding, they then move to pictorial representations and so on. But in fact, many researchers believe that the approach shouldn't actually be as rigid as that. So, for example, you may be familiar with this connections model developed by Haylock and Coburn. They suggest that a mathematical concept can be thought of as a network of connections between symbols, language, concrete experiences, and pictures. And they see the model as not implying a fixed sequence, but they are more concerned with developing teachers' awareness of the need to provide experiences so that children make connections and therefore develop understanding. So in other words, they're saying that it's important that children are exposed to different representations, move between them, see them alongside each other, so that they are making those connections. So with that in mind, I quite often use this as a diagram to show how children might, for example, be working with a concrete representation at the same time as the abstract representation. So we're looking at this intersection here, so looking at how we might be developing those representations alongside each other, seeing how one relates to another. Just give you a moment to read that. So here Barnby et al. Making a distinction between external and internal representations. It's interesting to note their findings that the external and internal representations may not be the same, and also that the personal individual nature of these internal representations. They go on to say, so we're going to be predominantly thinking today about the external representations that we might use, but we will return to the idea of internal representations later on. Moving on to consider why we might use representations, I'm actually going to start with a myth about using representations. This is taken from a recent NCETM article where they've identified a number of myths relating to representations, and I'll refer to more of these towards the end of the session. But to begin with, so if we do allow children to use representations to calculate answers, we need to be mindful not to allow that to continue indefinitely. Instead, as it's saying here, we need to expose the structure of the maths to avoid this dependency. So we will be exploring how to do this today. So the idea of drawing attention to structure is also referenced by the EEF in one of their guidance reports. And we can see here that the focus is on understanding rather than answer getting. This reminds me of when I asked some year 6 children to show me what was meant by 3 multiplied by 4. And the overwhelming response I received was 12. So I proceeded to ask the same question in a variety of ways. Can you show me? Can you represent? Can you draw a picture? Can you use equipment to show 3 multiplied by 4? And still they could only tell me 12. I think this suggested to me that the children had only ever learnt to memorise those 3 numbers going together, 3, 4, 12, with no or perhaps little understanding of what we might refer to as the structure of multiplication. Or perhaps I should say one of the structures of multiplication. And of course, the difficulty without understanding then comes when you're asked to recall a fact that you haven't memorised. And of course, your brain cannot memorise every single fact. So if you haven't understood a structure of multiplication, you don't have strategies to derive unknown facts. Whereas if you have an understanding of the structure, you might draw upon a representation to derive an unknown fact. For example, if I don't know what 8 multiplied by 7 is, I might consider or draw to mind an array of 5 multiplied by 7 and another array of 3 multiplied by 7 and combine these. On page 3 of our national curriculum, perhaps the part that we don't look at too often, just talk there about the need for children to move between representations. So another purpose of using representations might be to enable children to see connections that exist. So maths is actually full of connections, but it might be the use of representations that allow children to see those connections rather than believing each concept as being separate and unrelated. So at this point, you might want to pause the recording to reflect on your practice and discuss your responses to this prompt. For what purposes do you use mathematical representations in your classrooms? Are your children using representations to calculate answers? Are they therefore possibly becoming dependent on the representation? Or do you use representations to draw children's attention to the structure of the concept? Do you have any other reasons for using representations? So we'll now explore how we might go about making decisions about using different representations. And I've already mentioned the EEF, Education Endowment Foundation. These are two guidance reports that they publish. So the one on the left is for early years and Key Stage 1, and then on the right, Key Stages 2 and 3. And both of these reports made a series of recommendations based upon a synthesis of the research around maths education. And interestingly, both of the reports made recommendations relating to using manipulatives and representations. And as we start to look at more detail around those recommendations, we can see some very clear similarities between them, some slight differences, and we will be looking at some of these bullet points in more detail as we go through the session, starting with this one here, ensuring that there's a clear rationale for using a particular manipulative or representation to teach a specific mathematical concept. So considering that we've already seen the importance of structure, I think these bullet points are highlighting to us the importance of us asking ourselves the question, so which representation exposes the structure or concept most appropriately? And there might be more than one representation, so we might need to then make a decision about which to use or whether to actually show the same concept using multiple representations. So Drew's here highlighting the importance of careful consideration and planning. And she goes on to say, so it's important to evaluate the resources and representations that we might want to be thinking about using in the classroom by considering both their advantages, but also their limitations. So let's look at the concept of division to explore this a bit further. So division can be structured as sharing or as grouping, and depending on which structure we're focusing on with the children will influence the representations that we choose. So to start with, some language that is useful when we're talking about division: dividend, divisor and quotient. And this applies regardless of which structure we are using. And I think the correct use of language is really important. It doesn't specify in the national curriculum the need to use this language with children in primary school. However, I think it can be important to help children to explain their thinking and their reasoning, and also to give a common language so that everybody knows what we're talking about. We're not referring to that number or this number, we're actually using the specific terminology relating to division. So when we look at grouping as a structure, we are actually asking how many groups of the divisor are there in the dividend, or how many groups of the divisor can be made from the dividend. So the example we're going to look at, how many groups of 3 are there in 14? How many groups of 3 can be made from 14? So a useful representation can be Numicon. It's not the only representation I could have used, but the fact that the pieces representing the divisor are already in groups of 3, and I don't have to construct them from individual pieces, is an advantage. Just as a slight tangent here, what I'm actually doing here is unitizing. So this is where one object has a value other than 1, in this case 3. So mathematically, this is a very important concept which has uses throughout the primary curriculum. If any of you have seen the non-statutory guidance released by the DfE in June 2020, you will see that it features heavily in there from year 1 right the way through to year 6. But it is a concept that younger children can find difficult to make a transition to. So for a long time, their experiences of using objects are objects where we are emphasising that each object has a value of 1. And then we're asking them to now think about, okay, this is 1 object, but it has a value other than 1. So it is something that requires careful planning and consideration as to how we're going to introduce it to the children, and should be based on when they're ready for it. It does rely heavily on the idea of exchange, the idea that I could have 4 ones, or I could have 1 object that has a value of 4. The value is the same. With older children, they're required to unitise when, for example, they're working with fractions. So I might use a representation to show 1/8, but it might be 1 object or 1 representation with a value other than 1. So I'm able to see with the Numicon how many groups of 3 cover the 14. I can see clearly, again helped by the 3's already been in groups, along with my ability to subitise or see instantly how many there are, that there are 4 groups of 3 and a remainder of 2. So my quotient is 4 and I have a remainder of 2. So for the grouping structure of division, Numicon is a very useful and powerful representation. However, if I consider the sharing model or structure of division, the divisor now refers to how many groups I'm sharing the dividend between. I'm now sharing 14 between 3. Here, the Numicon is not appropriate. I cannot physically share the 14 between 3 without having to regroup, which overcomplicates the concept. So this is an example of what I mean by considering the limitations of representations. Here, Numicon is just not appropriate. Instead, I need to consider alternative representations. I actually need something that I can share. So I need individual items that I can move 1 at a time. So here I've just got 1 example of what I might use. So once again, I can see the quotient as 4 and a remainder of 2. So regardless of the structure I'm using, the answer or the quotient is still the same, but how I get there is different in each case. So this slide's just a summary of the different structures, the similarities and differences that exist between them. Often with children, we are likely to use a context to show the differences. So that might be, I have 14 flowers, I put 3 in each vase, how many vases will I need? Or I have 14 flowers, I share them between 3 vases, how many flowers will I put in each vase? The language of grouping and sharing tends to be most familiar to us, and the language we are likely to use with children. However, recent publications, such as the DfE non-statutory guidance and the NCETM Mastery Professional Development materials, have started using the words quotative and partitive. So I have just included these here for reference. And we can see in the Mastery Professional Development materials in Spine 2.6 for Year 2, all about structures, quotative and partitive division. And I think these materials can be really useful for clarity on the different structures and examples of the representations that we might use to expose those structures. If you're familiar with them, you will know that the format is that they identify a number of key teaching points for each of the spines. So moving on to look at another example of the importance of careful selection of the representation to show the structure. I'm going to look at adding a 2-digit number and some ones. And although there are different structures I might be using here, different strategies, I'm going to look at the structure of partitioning the ones. So I'm going to show you this in the abstract initially, and then we will consider some other representations. Actually, I think it's important to point out here that a prerequisite for the children in working on this concept is that they have a really secure understanding of number bonds for all numbers up to and including 10. So before the children are working on this, I would expect in this example that they know the different ways that they can compose 7 from 2 numbers. So they might know that it's 6 and 1, know that it could be 4 and 3, etc. And what they're doing here is then applying their knowledge of those number bonds. So here, as part of that application, they're going to be involved in some decision making. So I know all of these ways to partition 7. How do I go about deciding? So some of the questions we might ask children when they're working on this are these. So why, for this calculation, do we partition 7 into 5 and 2? Why do we not partition the 7 into 4 and 3 for this calculation? So again, I'm drawing their attention to the structure. So I've shown you the concept in the abstract form as an abstract representation. You might want to pause the recording at this point to consider what the concrete representation might be that sits alongside that abstract recording. Put some ideas on the slide here, but you might have some other ideas. So in other words, I'm asking you to think about which of the resources could be used to represent how we partition the ones. Maybe also think about which ones have limitations, which ones wouldn't you use and why. You might also want to consider whether there are any pictorial representations that might be useful. So in order to develop this concept and structure a little bit further, I might then ask the children to explore other, what I'm going to call related calculations, along with the prompt question, what do you notice? So you might want to explore these calculations with the resource that you chose. How would you use the resource to represent these calculations? And once again, this is about exposing the structure. So I want the children to notice and to actually make a generalization that in these calculations, I always partition the ones number into 5 and some more because I'm adding on to 25. And the representation that you've chosen should allow you to see how that is true. I might then For example, change the first number to 26 in each of these, and ask you to consider how does that change the structure, and how does it change how I partition the ones number. So again, you might want to pause the recording at this point to consider how these sets of calculations compare. What do you notice? What's the same? What's different about the set on the left and the set on the right? If I ask the children to focus their attention on the set on the left, the calculations are what I would call unrelated or random. So therefore the focus can only ever be about finding an answer. Whereas the set on the right have been carefully chosen to expose the structure with something for the children to notice. So this is an example of what we call procedural variation, which might be a term that you are familiar with, particularly if you have been involved with the Maths Hubs. And they use these definitions. So we could see in the examples on the right that there was a connection between the calculations. But if we do want children to look for and recognise these connections, we have to make sure that there are connections there for them to make. So I now want to continue exploring the idea of careful choice of representations, depending on where we want to draw children's attention. And we're going to look at the concept of representing numbers. So I would consider the examples on this slide are quite typical of what we might see in published resources, asking children which number is represented in each example. So as you can see here, I focused on 2-digit numbers, but could just as easily have included examples of larger numbers, decimals with 2 decimal places, for example. So as we move through the next few slides, you might find it useful to consider the types of number you would be asking your children to represent. You might also want to pause the recording here to consider what the purpose of this is. What is it that we want children to notice about the numbers when they're looking at these representations? So because here we've got 22 represented on a bead string and 34 with base 10 and 29 with numicon, for example, we can see that we're changing both the number being represented and the resource being used to do so. And I'm not convinced that changing both the resource and the number allows children to notice what we want them to notice, which I think is an understanding of the number system and the relationships that exist within it. So how one number maybe compares with another. Where does 34 lie in relation to 29, for example? But because we've used different representations, I'm not sure that's easy for the children to make those comparisons. So I'd like to offer an alternative approach. So my alternative approach is going to be to fix the choice of resource. So in my examples, I'm going to just focus on the bead string. That's just one example of what I could have chosen. So I'm going to fix the bead string, and I'm going to carefully choose the numbers that I'm asking the children to represent. So you might want to pause here to do this for yourself. You'll notice I've written these in words, and that's really just to highlight the importance of, initially I'd be asking the children or presenting these to the children verbally initially, rather than in the abstract. So ideally, I'd also want the children to represent each of these using a different bead string, so that they could then lay them underneath each other and make comparisons. So that's where my questions come in here. I'm prompting them to notice similarities and differences. And I really want them to see, for example, how 33 is similar and different to 35. I want them to see how 33 is similar and different to 53. If they've used different resources and randomly selected numbers, as on the previous slide, I don't think that's easy for them to do. So as well as giving children opportunities to represent numbers on a bead string, I also want to give them opportunities to do the inverse of that. Can they identify which number is represented on the bead string? Can they move between different representations? So that might look something like that. And again, the numbers I've chosen are carefully chosen to focus their attention on the structure. So actually we've got lots of 2s and 3s going on, but they mean different things in the different examples. I might then develop this a little bit further by asking the children something like this. And my thinking here is that I'd perhaps pose the question to you: do children always see representations with 10s on the left and 1s on the right, which could lead to misconceptions? So far I've taken the approach of fixing the resource and changing the numbers being represented, but I could do the inverse of that. So I'm going to ask you to have a go at doing this. So this time I'm going to fix the number. So the number is 17, and I'm going to ask you to use any resources that you have available to come up with different ways of representing 17, and then consider these as questions. So here are some examples of representations of 17. As it is a team number, some of the representations allow me to see the 10 and 7 structure more easily than others. So for example, I can see that really clearly with the Numicon. I can see it quite clearly with the pre-printed tens frames, with the bead string, and with this representation here. So this is a rec and rec, and actually if I look closely I can see the 10 and 7 in different ways, whereas the counters, the individual items, in the arrangement that they are in here, it isn't easily to see that there are 17. I would actually have to count them to check. So one thing I might be asking children to do is to think about how they could organise them so that it is possible to see how many there are without counting. I haven't used them here, but I could have included an example of 17 constructed or composed from place value counters. And I go back to the concept I mentioned earlier of unitizing. So whenever we use place value counters, we are unitizing. So one counter has a value of 1, 10, 100, and so on. But what's also quite different with those compared to the unitizing that I'd be doing with, for example, the Numicon, is that they are not proportional. So With the Numicon, the tens piece is 10 times larger than the ones piece, but with place value counters, they all are the same size regardless of value. So I think we have to be quite mindful of using those with children. They are conceptually more difficult than perhaps some of the representations here because of that non-proportional relationship. And then leading on from that, when I start to use coins with children, they are again unitizing, so one object having a value of 10, but as well as not actually having a proportional relationship, we have an added complexity here in that we have one object with a value of 5 that is smaller than the one object that has a value of 2. And I think when we start to unpick some of the things like that, we maybe start to see why coins can be quite difficult for children. I know that's not the only reason, but it is one of them. So I know the curriculum talks about or sets the expectation that Year 1 children know the value of all coins and notes, but I think we again have to think carefully about when we introduce those to children. If for example, we've got children who let's take base 10 equipment, for example, if they are not secure in the idea that the rod has a value of 10 and maybe they're insisting on counting each time, then because they're not secure in that unitizing where there's a proportional relationship, they're really probably not ready to be using coins. So again, I might develop this a little bit further by asking the children to do the things here, adding their own representations, correct and incorrect. And again, I might then develop this a little bit further. So up until now, I've fixed the number and now changed the resource. Now just going to fix the number and the resource. And here I'm asking the children to consider whether each of these represents 34 and to explain their reasoning, perhaps by using prompts, how do you know, convince me, or prove it. And here I've got my, what I would call typical representation of 34, 10s on the left, 1s on the right, but important that the children recognise that the arrangement of those 10s and 1s doesn't always have to be in that format. I've got an example here for them to think about why that doesn't represent 34. I might ask them to think about, why have I chosen that? What mistake might somebody be making if they think that does represent 34? And then here I've got this idea of going on again of exchange, that idea that 10 can be represented with one stick or rod, but it can also be 10 1, so that exchange or equivalence going on there. Sticking with the idea of structure, I want to draw your attention to the increased focus on structure in recent publications. So this slide, these images here are taken from the DFE non-statutory guidance I mentioned earlier, and shows what they refer to as different additive structures. So although this is in the Year 1 guidance, you might want to consider whether the older children in your school have an understanding of these structures. And the guidance just go on to talk about both additive and multiplicative structures right the way across from Year 1 to Year 6. The structures are also mentioned in the professional development materials. So Year 1 is 1.5 and 1.6. In the DFE materials, I'm just going to briefly talk about these. In these materials, the format of them is that they have identified a number of what they call ready to progress criteria, which is, in other words, what they're considering to be the priority areas for each year group. So this text in purple, in the purple box, is one of the criteria for year 1. And then the materials go on to give some teaching guidance. And the bit I particularly want to draw your attention to is the final sentence here. All examples used to teach this criterion should use quantities within 10 and be supported by manipulatives or images. And this is to ensure that pupils are able to focus on the structures and it not being about working out answers. So if we just look at these structures in a bit more detail, if we start with aggregation, and the suggestion is very much that the children are starting working with either concrete or pictorial representations, and they are describing what is happening. So that might look something like this. There are 5 flowers in one bunch, there are 2 flowers in the other, there are 7 flowers altogether. So aggregation is actually all about the coming together, the combining of 2 or more quantities. So initially they're just talking about and describing the structure in of course a context. Before moving on to the written form, how we could write that. But also, and I think this is really important, is then that connection between those two, between the concrete or pictorial and the abstract. The focus being here on adults modelling these sentence structures, the 5 represents, the 2 represents, and also asking children to be talking about the structures in this way. Then we've just got a similar approach for the other structures. So partitioning. And both aggregation and partitioning relate to a part-whole relationship. Goes on to talk about the children also working with the structures of augmentation and reduction, and actually both of these refer to an increase or a decrease, so a change in some way. It's saying there that takeaway should only be used to describe the subtraction operation in reduction contexts. In a partitioning context, we're not actually taking away. So augmentation. And for both augmentation and reduction, we have this first, then, now scenarios. We start off with a quantity, something happens in augmentation, an increase, reduction, a decrease, and then we've got the new quantity. The guidance goes on to give examples of other representations that we might be using. And I have just put page numbers in there. These are all from the year 1 documentation if you want to go and look at those specific parts. It also then talks here about the focus here being on the structures, that it isn't about correct calculation of solutions. So you might want to once again pause the recording here to consider these as prompts. Returning to the guidance reports, I want to pick up on these as bullet points: ensuring that the children understand the links between the manipulatives and the mathematical ideas or concepts that they represent. Because although as adults we will have a really clear idea about the representations we're using, children do not always make the connections. We've just seen some examples of how important it is that we're asking the children to talk about what the 5 represents, for example, in the context of the flowers. But I just want to perhaps draw your attention to another example of that. So this might be something you've already seen. It's certainly not new. It's one of the NCETM videos that came out a few years ago, but if you haven't seen it, you might want to watch it now. So this can be found on the site within the Teaching for Mastery section. Then go into Mastery Magnified, primary lesson videos, and then this Year 1 lesson on difference as a form of subtraction. And you can either watch a whole lesson, but the bit I want to draw your attention to is this, subtraction as take away. It's only a 5-minute clip, so you might want to pause the recording now to watch that and consider particularly how the teacher is ensuring that the children develop an understanding of the links between the manipulatives, counters, and the mathematical ideas that they represent. When you watch the NCETM videos, you're probably aware that there are accompanying PowerPoints to draw your attention to particular features and to prompt your thinking and discussions. So that's what these following slides are. We, again, maybe as adults, take for granted that today one counter represents one car, but tomorrow the same counter might represent something completely different. We have no difficulty in switching between these representations, but we might ask ourselves whether the children we teach are clear about what the manipulatives we use represent, and are they able to verbalise their understanding? Do we question the children about what the counters or the cubes or whatever else it might be represent? Do we expect them to explain in full sentences? And do we expect this of all children? So this idea of children developing their own representations links back to the guidance reports of children representing problems in their own way. So we've looked at the importance of children understanding the connection between the manipulatives and the concepts being represented, and to develop this further, I will now share this quote with you. So Sousa here is implying that the concrete and pictorial representations need to be shown alongside each other in order for the teacher to explain how they're connected. And we could take this further to think about how showing concrete, pictorial and abstract representations alongside each other to support children in making the connections referenced by Haylock and Coburn earlier. So let's go back to our previous edition example. So we began with the abstract. We also considered concrete representations, and I've just chosen one here to focus in on, the bead string, but I'm also going to show a possible pictorial representation in the form of a number line. And although Sousa states the need for the teacher to explain the connections, I've personally found it helpful to use questioning to draw children's attention to similarities and differences between the representations, and also to check their understanding of the representations. So what I mean by that are things like, I might be asking them, so this 25 that I start with on the number line, where is that on the bead string? The 7 beads that are here on the bead string, Where are they in the abstract recording? Where are the red beads? Where are the white beads? Where is the 30 in each of the representations? Where does that come from? Why is it important? So I can't assume that the children will make the connections independently. I need to draw their attention to them through displaying the representations alongside each other and questioning them. So I think the following quotes highlight exactly that. So it's really the importance of those interactions and discussion that we have to support the understanding. And we can see exactly the same in the, interesting in the early years and Key Stage 1 guidance report, but I think we could suggest the same for Key Stage 2 and 3. So just sticking with these reports, I just want to pick up on this part here. So I'm asked quite often, yes, it's all very well children using resources and representations, but how do we avoid them becoming dependent on them? And Galeri talks about this. So we're actually now coming back to that idea we had earlier of those internal representations. She also goes on to say this. And I think this phrase here, this idea of a transitional stage is really important. So we don't want to allow the children to use the resources one day and then suddenly whip them away and say, no, you're not going to use those anymore. I think we need a kind of step in between those. So here the suggestion is that the resources could be covered or hidden. I'm going to just suggest a slight adaptation to this that I've used with a lot of children, and it's been really successful. So initially, of course, the children use the resource or the representation quite freely. If we want to then think about how we manage that transition, the next stage might be that the resource or representation is visible but not touched. So it might be, let's just take the Numicon example, the children have the Numicon on in view, so it might be in the centre of the table, but we're encouraging them to not pick it up and manipulate it. So it might be, once again, using interactions, so encouraging them to think about, so picture which pieces of Numicon you're going to need to use, what are you going to then do with them, and then the next stage being that they're then covered or hidden. But I think that middle part can be really useful to avoid that scenario of the resources are there and then suddenly they disappear. I'm not sure that's always helpful for children. So just final kind of few slides really. Just coming back to the NCETM article I started with, just some of the myths. You might want to pause the recording to look at these in a bit more detail. Talking here about representations being useful for all learners, and I certainly think in recent years we've made quite a big shift in terms of a wider range of children accessing resources and representations. I think with this one, perhaps depending on the children, or although we as teachers might be choosing the representations, we might actually engage children in dialogue about why we've chosen particular representations, or maybe why we haven't chosen other representations to support their understanding. And then this final one here. And again, I think in recent years, this particularly thinking about the example in brackets here, fractions as pizzas, I certainly think we have moved away from the idea of only using pizzas, cakes and other circular representations for fractions, and certainly when we look at published materials we see a much greater range of representations. Talks here about multiple representations, and again the hubs talk about this being conceptual variation, showing the same concept in a variety of ways. So bearing in mind what we've just focused on, you might want to pause the recording now to think about how you go about making decisions about which representations to use and how you use them. Just going to draw your attention to the EEF self-assessment guide. So there is one of these for each of the recommendations in the Key Stage 2 and 3 guidance report. This is freely available on the website. You might find it useful to have a closer look at. You'll certainly see some of the ideas that we've explored today referenced here. So my final question, the one that I finish all sessions with, is I'm just giving you some time to think about what you're going to do differently as a result of this session. I hope it's been useful in terms of considering how we go about making decisions about using representations, but in light of the research. If you would like to read further research, I just put some websites here where there's a lot of research available, quite accessible research as well, along with the subject associations. There are obviously subscription fees payable with those, but they are really useful sources of research. And then finally, the references from the quotes and research that I've been using today. So as I say, I hope it's been a useful session. Please don't hesitate to get in touch with any questions or queries or just any comments that you might have. Thank you for watching.